All right, good morning. Happy Monday. All right, the first thing I want to talk about today is the Radian activity. Um, let's see if how things went with this. So if you notice in the directions, I omitted a protractor. So sometimes students get confused about a compass and a protractor. This is a protractor. A compass is the thing that looks like this, where you draw a circle with it. It's not a compass as far as direction, north, south, east, and west. There's two types of compass. We're talking about the mathematical one. So basically, I did not say you could use this. So because I didn't want you to draw an angle of 57 plus a little bit degrees. So that kind of missed the whole point of this activity. So I asked you to draw 3 circles, and actually the radius, if you're wondering, well, she wants us, if we don't have a compass, she wants us to use a string. How am I going to get exactly 3 inches? How am I going to get exactly 2 inches? And the point is, I didn't really care. It doesn't matter, if you're drawing a radius of 3.5 inches or 1 3/4 inches, or if you're off, it doesn't matter. So does somebody, and also I didn't specify whether you should draw a circle on each and separate sheets of paper or on one sheet. But there were a couple students that drew it on front and back. It'll be hard to discover what's going on if you drew, it's not wrong because I didn't say, but it is harder to see if you drew circles on the front and back of papers. So, did anyone in this class draw concentric circles? So did anyone draw the circles like this? Did anyone do that? No? Well, this would have been the easiest way to see what's going on. But that's okay if you didn't. All right, so go ahead. What did you guys discover about what I was trying to get you to do on problems 1 through 4? What did you guys discover?
What we mainly discussed was how no matter the radian, the degree always looked the same.
Okay, so let's be really cautious about what we're saying. Do you mean okay, so we were discovering what 1 radian was. So did you mean the radius?
Yes.
All right, so can you say it again, or can someone else say it?
Okay, so no matter the radius, the angle measurement for the radian always stayed the same.
Yes. Yes. So no matter the length of the radius, the measure of the radian always stays the same. So let me ask you this. If I had you go outside and draw a radius of 100 yards, could you get the radian? So the question is, how do you get 1 radian? So we talked about the radius. It doesn't matter what the length of the radius is, but what's the important fact here?
That the radian
Radian
always stays the same.
equals 57 degrees.
No. The radius is equal to what? The radius, let's look at 3 inches. The radius is equal to what? What is this length equal to? the radius is equal to the arc length. So when the radius 3 is equal to that arc of 3, you're going to get 1 radian. So if the radius is 100 and the arc length is 100, you're going to get 1 radian. If the radius is 1 and the arc length right here is 1, you're going to get 1 radian. If your radius is 2 and your arc length is 2, you're going to get an angle that's 1 radian. So that's what I have to have. You need to know that. Now, the thing is you cannot measure an arc with a ruler. So some people were trying to measure an arc with a ruler. You cannot measure an arc with a ruler. So what did you use? How can you measure an arc?
With a compass?
Yeah, but it wouldn't be very accurate. So.
A protractor?
Can't use a protractor. That wasn't in the list.
You used a string.
Use a string. So if you measure 3 inches on the string and you take the string and wrap it around the arc and make sure it's at 3, you could get the measure of the arc. If you had a string that was 5 inches and you measure around 5 inches, you're going to be able to get 1 radian. So that was the point of the string, is you cannot measure an arc with a straight edge. So the 5th question was, in the space below, write a paragraph describing your observation of the 3 illustrations in regard to the measurement of in regards to the angle measurement of 1 radian. So somebody tell me again, what was the discovery?
That of the radius is equal to the arc length, you have 1 radian.
That's exactly right. When the radius is equal to the arc length, you can get an angle that is 1 radian. So if I ask you what's a radian, you're going to hold your hand up and do this. I don't care that it's 57 degrees. I care that you know that it looks like that. All right, so everybody show me 1 radian. And it has to be your left hand because it has to be in standard position. So you cannot use your right hand. It's got to be your left hand that shows the 1 radian. All right, now, number 6. How many radians are there in a half a revolution? I don't know. Well, let's think about it. If you're telling me that 1 radian looks like that, wouldn't that be 2 radians? Wouldn't that be 3 radians? So what's half a revolution?
About 3
So what's the measurement from here to here in radians?
3.
Plus a little bit more, right? So do you know a number that's 3 plus a little bit more?
Pi.
So now you know. Where did pi come from? Where did this number come from? It's pi radians. It's pi radians. Half a revolution is pi radians. It's 3 radians plus a little bit more. 3.14. So what would a full revolution be? What would 1 revolution be? I don't know, draw it out. Draw another radian, draw another radian, draw another radian. So that'd be 4 radians, 5 radians, 6 radians. What would be a full revolution?
6 and a little more.
Which is what?
2 pi's.
2 pi radians. 2 pi radians. So if you did another revolution, it'd be 3 pi radians, 4 pi radians, 5 pi radians, 6 pi radians, 7 pi radians. So we're going to use that as a landmark that all of the odd ones, pi, 3 pi, 5 pi, 7 pi radians are going to be over here. And over there is going to be 0 radians, 2 pi radians, 4 pi radians, 6 pi radians. So now you know where the number pi came from. It's not pi. It's pi radians, which is 3 plus a little bit more radians. So on an exam, if I asked you to draw me 2 radians, you're just going to hold your hand up, right? And do 2 of those. If I asked you to give me 3 radians, you're just going to do 3 of those, right? That's not like rocket science. It's just, that's a radian. So draw 3 of them. Draw 4 of them. If I ask you to do negative pi radians, you would be rotating clockwise. So this would be negative pi, negative 2 pi, negative 3 pi, negative 4 pi. Now, okay, so let me not get ahead of myself. Let me just finish. Let me go on with the lesson here. So for example,
Is this continuing 17.1?
yep, it's going to be continuing for a while probably. If I asked you to draw 2 radians, in standard position, you would just make a little mark for 1 radian, make a little mark for 2 radians. You're going to draw the angle and name it. That's about 2 radians. If I asked you to draw 3 radians, that would be about 1, that'd be about 2, and about 3 would be there. Name the angle. So in trigonometry, we like to measure angles using radians. It's going to be easier. So measuring with a protractor would be harder. Measuring with radians is going to be easier. So an acute angle in radians is going to be the angle, theta, is going to be less than pi over 2 and greater than 0. Because think about it. If this is pi radians over here, wouldn't this be half a pi? Wouldn't this angle be half pi?
Yes.
And wouldn't this angle be a fourth of pi? Follow me? So we're going to be going in that direction. So an acute angle has to be in the first quadrant, and it would be between 0 and pi over 2, or half a pi. Half pi radians. Now, remember what I told you before, that if I don't put a measure, radian measure is implied. So this would be pi over 2 radians. If I didn't write that, it would be radians automatically. So what about a right angle? Well, in radians, it's going to be pi over 2 radians, or half pi. An obtuse angle would be in the second quadrant, so the angle would be less than pi over 2 radians, and greater than pi radians.
Could you move your camera a little bit, please?
Hold on, that's not right. Yeah, hold on.
Or to the second whiteboard, please. Oh, thank you.
All right. It would be greater than pi over 2 radians and less than pi radians. A straight angle would be pi radians. Now, the world isn't perfect, and so our answers aren't gonna, it's gonna get worse than this, right? I mean, we're gonna have pi over 12 radians, 5 pi over 12 radians, 6 pi over 7 radians, 11 pi over 12 radians, 15 over 17 pi radians. So let me draw this out for you, just so you can conceptually know what you have. Did Ms. Fresco go over this?
I think this would have came up during distance learning on like Alex.
Oh, okay. She used Alex. That's good. Alex is a good program. Yeah. Quadrant 3. Quadrant 4. All right, now, in standard position, that would be 1 radian, 2 radians, 3 radians, 4 radians. That's kind of not good. Five radians, 6 radians, okay, 5 radians, 3 radians, 4 radians, 5, and about 6. So this would be 1 radian, 2 radians, 3 radians, 4 radians, 5 radians, 6 radians, plus a little bit more. And like I said, if you're drawing an angle in standard position, this would be 0 radians. This would be, I need to put arrows on these. This would be half a pi or pi over 2 radians. This would be, look over here, 2 pi over 2 or pi radians. This would be 3. So this would be pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2 would be 2 pi radians. And you can keep going. 5 pi over 2, 6 pi over 2 would be 3 pi over 2 radians, 7 pi over 2, 8 pi over 2. So let's see the two together. Now listen carefully. If you're working in degrees, do not convert to radians. If you're working in radians, don't convert to degrees. It's like decimals and fractions. If you're working with fractions, work with fractions. If you're working with decimals, work with decimals. There are special times that you convert, and I'll show you how to convert, but in general, you don't. All right, so if you have a revolution, making a table, what does it look like in degrees? And then what does it look like in radians? So a fourth of a revolution would be 90 degrees. also known as pi over 2 radians. A half of revolution would be 180 degrees, or pi radians. 1 revolution would be 360 degrees, or 2 pi radians. And 2 revolutions would be 720 degrees, or 4 pi radians. So these, by the way, these are just examples. This is nothing you need to memorize. But here's the point. You can have any number of revolutions with angle rotation. So an angle could rotate 12 times. An angle could rotate 12 revolutions. An angle could rotate 100 revolutions. So there's no limit to the number of revolutions. So let's make a note here. You can have any number of revolutions with angle rotation. All right, now we're going to get into the nitty gritty things. Like, what if it's not a radian? What if it's part of a radian? What if it's a sixth of a radian? What if it's like a third of a radian? So you must know this, and you must know this really, really well, okay? This is drawing angles in standard position. What's standard position mean?
On the origin.
The vertex has to be at the origin, and what? Go ahead, I'm listening. The vertex has to be at the origin, and what?
The initial side lies on the positive x-axis.
Yep, the initial side lies on the positive x-axis. All right, now, what we're gonna go over right now are common angles. So your angles are gonna be harder than this, but what we're gonna do, we're gonna look at an angle, we're gonna look at it in degrees, and then we're gonna look at it in radians. Because remember, the 2 ways to measure an angle is in degrees and radians. All right, so can you guys see this okay?
Yeah, we can see it.
Okay, I'm gonna move this down because I need to draw 5 of them. All right, you ready? If I divide the top into 6 parts, 1, 2, 3, 4, 5, 6. Can you see those are equal parts? Can you guys see that?
Yeah.
There's 6 equal parts. What if I asked you what this angle is? What would you say that angle is?
Just that blue one?
Uh-huh.
1 radian?
Okay, remember that 1 radian is this. That's 1 out of 6 parts. So 1 out of 6 parts is going to be your 30-degree angle. Now, I don't know about you, but that's confusing. What do you think it is in radians? 1 out of 6. What do you think it is?
1/6 pi radian, or pi divided by 6.
Right. Watch. It's 1/6 of pi. Well, of in math means multiply. So wouldn't that be pi over 6 radians?
Yeah.
So 1/6, see, look up here. This is very important that you get this. This is pi over here, right? So if I divide it into 6 parts, wouldn't it be 1/6 of pi? And of in math means multiply. So wouldn't that be pi over 6 radians? Let's do another one. Look up here, please. If I divide this into 4 equal parts, 4 equal parts, and I ask you to tell me what this angle is right here. What's that angle?
It would be a fourth of pi, 45 degrees.
Well, first of all, it's 45 degrees. But what would it be in radians?
1/4 of pi.
And 1/4 of pi would be
Pi divided by 4.
pi over 4 radians. So see how it's going to be easier to work in radians? So the third example is I'm going to disregard that line in the middle, and I'm going to draw 3 equal parts. 1, 2, 3. You see it? 1, 2, 3. I don't need the line in the middle. If I drew that and I asked you, what is this angle right there? In degrees, it would be 60 degrees. Do you remember Ms. Fresco talking about the 30, 60 triangles?
Yeah.
That's where this is coming from, because if I made these out of if I made triangles out of these, I could draw a line straight up and down and make triangles. That's where these degrees are coming from also. Anyhow, this would be what? 1/3 of pi, and 1/3 of pi would be pi over 3 radians. And then if I asked you to give me this angle, which is a straight angle from here to here, call it theta, that's a straight angle. It would be 180 degrees, or pi radians, right? And a full revolution, you draw it like this all the way around and put theta. A full revolution would be 360 degrees, or 2 pi radians. All right, these are common angles that you need to know. So you need to memorize those. All right, now you guys ready to draw and name an angle in standard position? Because this is the next assignment. Okay, so we're going over the next assignment right now. We're not doing the book work. This is going to be another sheet of paper that I made a separate sheet of assignment for. So here we go. All right. So the next assignment is to draw and name an angle in standard position. And like you said, standard position means 2 things. Make sure the vertex is at the origin, and make sure that the ray, right, the initial side coincides with a positive x-axis. So you're going to draw a name and angle in standard position, and you're going to state the quadrant. of the angle. And that means you're looking at the terminal side, right? All right, there are 5 steps. Number 1, draw the coordinate plane. That means now you have to label the X and Y axes. If you do not label the X and Y axes, the pre-calculus teacher and the AP calculus teacher is going to flip out. You have to label the axes now. X and Y. The second step is you're going to draw the appropriate fractional parts. And I'm going to show this with examples, so don't worry about it, just write it down. Then you're going to draw an angle in standard position. Number 4, you're going to draw an arrow to show the rotation. Slash angle. And number 5, you're going to name the angle a Greek letter. And don't forget, you could say number 6 if you want, that you're going to have to state the quadrant. All right, now I'm going to start with degrees and then we'll move on. So if they ask you to draw a 350-degree angle, you cannot use a protractor. So what we're going to do is we're going to follow the steps. You're going to draw the coordinate plane, X, Y. And you can draw a circle if you want. We haven't talked about the unit circle yet. And so in my notes, I'm not showing a circle per se. So I think I'll just continue with this because it makes it cluttered. All right, so this would be 0 degrees. This would be 90 degrees, and this would be 180 degrees. So 90 more would be 270. Now, do you guys all agree that the angle is it's in the 4th quadrant?
Yeah.
Because when you do a full revolution, it's 360. So do you believe it's between 270 and 360? Well, you can't just go, oh, well, this is what it looks like. You can't do that. You have to divide it into fractional parts. So watch this. So that would be 270 plus 45. So what's 270 plus 45? 270 plus 45 would be what?
315.
Oh, really? All right. There we go. So if it was in between there, you'd have to divide 45 in half and put another, you know what I mean? You'd have to come up close to the angle. All right, so let's draw it. So the vertex is there. You're going to show the rotation. And you have to name the angle. So we drew the appropriate fractional parts. We drew the angle in standardization, show the arrow, name the angle, and now we have to state the quadrant. So what quadrant is this angle in?
4.
Right. Yeah, 4.
So let's do some more. So in other words, you can't just guesstimate where the angle is. You have to show how you're getting the angle. So what about negative 210 degrees? Well, let's draw the coordinate plane. And like I said, you could draw a circle if you want. So now we're going in clockwise direction. So this would be 0 degrees, negative 90 degrees, negative 100 degrees, because we're going this way. You guys with me or not?
Yeah.
All right. So 90 more would be negative 270 degrees. So this negative 210 is in here somewhere. So you do realize, look up here real quick. This would be 30, 45, 60. Do you get me? 30, 45, 60. So if I added 30, that would be 30, 60, 90, right? 30, 60, 90. Wouldn't negative 180 minus 30 be negative 210?
Yes.
So you're going to draw your angle in standard position. So you're going to have your ray. You're going to draw the rotation. You're going to name the angle alpha and state the quadrant. So what quadrant is this in?
2.
Quadrant 2.
Right. So we're doing easy angles right now. This does get worse. You know, it's not going to be like 315. It could be 317. It could be 324. It could be anything. So if this was 0 degrees and this was 90 degrees, isn't half of 90 45? So drawing the angle in standard position, your initial side would coincide with the positive x-axis. There's your angle beta. And what quadrant is this in?
1.
Quadrant 1. All right, now, I personally hate graphing in degrees. Watch how much easier radians is going to be. So I'm just letting you know, we do not work in degrees that much. Okay, now think about this. The denominator tells you how many parts. So if this was a 4, you're going to break it into 4 parts. Look up here, please. If this was a 7, you'd have to break it into 7 equal parts, and you may not use that line. If it was a 12, you would break it into 12 equal parts. If it was a 15, you would break it into 15 equal parts. So I'm breaking this, pay attention. This is broken into 4 equal parts. You can see the parts, right? 1, 2, 3, 4. But this says 5 pi over 4. So since it's an improper fraction, you would have to break the bottom into 4 equal parts also. Pay attention. This would be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and I know I'm right because that's pi. 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4. So you just count like that, however many you need to go. So I think we're ready to do the angle. So the angle in standard position, if this is 4 pi over 4, wouldn't this be 5 pi over 4? And wouldn't the angle look like this? Yes, no? What
Yeah.
quadrant is this in?
3.
You're following the steps, right? Graph the coordinate plane, draw the appropriate fractional parts, draw the angle in standard position, draw the arrow to show the rotation, name the angle, state the quadrant. How about this one? Negative 2 pi over 3 radians. Well, now we're not going to divide the top into equal parts. We're going to divide the bottom because this is a negative angle. And this right here isn't helping me, so I'm going to erase it because I have to draw 3 equal parts. Still doesn't even look right. You're going to do the best you can. That looks like 3 equal parts, right? 1, 2, 3. So if you were going to count 2 out of 3, this would be negative pi over 3, negative 2 pi over 3, negative 3 pi over 3, which is negative pi radians. Do you guys see what I'm talking about? So your angle in standard position would be rotated to there, and you're going to name the angle phi. Don't forget to draw rays. You're not drawing line segments. So it's the rotation of a ray. So make sure you put arrows on it. Okay, what quadrant is this in?
Looks like 3.
Let's do one more. (13 pi over 5 radians). So that's a positive angle. How are you going to divide up the top? How many parts?
By 5?
5 parts. So you're going to try to draw 5 equal parts. So 1, 2. This is kind of tricky at first, but you'll get used to it. So 3, 4, 5, just like pieces of pie. 1, 2, 3, 4, 5, right? So if you look up here for a second, this would be pi over 5 radians, 2 pi over 5 radians, 3 pi over 5, 4 pi over 5, 5 pi over 5. So we want 13. So if this is kind of a landmark, 5 pi over 5 radians, don't we have to divide the bottom into 5 parts too?
Yes.
So this would be 1, 2, 3, 4, 5. So do you guys believe that this is 10 pi over 5 radians?
Yeah, because 5 and 5 on makes 10.
Well, this is pi, that's 2 pi. Remember, the odd pi's over here and the even pi's over there. So see how you can cheat and you don't have to like count like we're counting. So at the beginning, you'll count like we're counting, but then you're going to use these as landmarks. This is 5 pi over 5. What would this, if this is 10 pi over 5, what would this be over here again?
15.
15 pi over 5. And what would that be over there?
20.
20 pi over 5. And what would it be if you went another rotation?
25.
25 pi over 5. And then this would be 30 pi over 5, right? 2, 4, 6. So that's what I do is I use those horizontals to help me graph. All right, so we want 13. So one revolution is 10 pi, 11, 12, 13. So watch how I draw this. We made one full revolution and had to come back to here, right? Yes, no?
Yeah.
So one full revolution was 10 pi over 5 radians, 10, 11, 12, 13 pi over 5 radians. And what quadrant is this in?
2.
It's where the terminal side lies, and it is quadrant 2. All right, now, I have not posted this assignment yet, but I'm going to post it right now. And if you notice what this says, it says draw and name an angle in standard position. And the first problems are in radians, the second problems are in degrees. I would also state the quadrant, because on an exam, you're going to have to state the quadrant. So I would add that. So what you're going to do is you're going to go to your Math Wizard teams, and you might have to hold up your papers when you graph these, but you're going to start doing these problems. You can either do all the radians, or you can go back and forth. I don't care the order, but this will be the next assignment. Okay, and I will post it right now. All right, does anybody have a question about drawing or name? I'm not done with the lesson. I got like 20 more pages left. So anybody want to ask me a question about drawing and naming an angle in standard position? All right. All right. So I'll let you loose to your Math Wizard teams. I will post this, and you'll see this assignment. Let's see here. So the Radian activity is due Wednesday night. This is Monday. I'm going to make this one due on Wednesday night also. So this will be due on Wednesday night also. So you should be done with the Radian activity. If you're not, you should be able to do it quickly. This will be due on Wednesday. All right. All right. So I'll go ahead and make the due date, and I'll post it, and I'll see you in your Math Wizard team. Any questions? All right.
No return time?
What's that?
There's no return time? Like
I wasn't going to, but I better. So let's report back at 2:05, because there might be some problems. So we'll report back here at 2:05. Okay, thank you. All right. We're back in WebEx. Just a couple of reminders. First of all, remember that positive angles go counterclockwise, negative angles go clockwise. Also, if a terminal side of an angle lies on an axis, it's called quadrantal. In other words, it's not in a quadrant, it's in between quadrants, and that's what quadrantal means. All right. All right, do you guys want to ask me any questions about this assignment?
I have a quick question. For a number
Yep.
like number 16, do we have to find the exact measurement, I guess?
Yeah, you have to come close. Yep. So like on an exam with me, if you didn't show how you're breaking it down, I'd have to mark it wrong. Like you just can't guess and go, oh, it's around here somewhere. So what number did you say? 16?
16.
So number 16 is negative 150. So this would be 0 degrees, this would be negative 90, and this would be negative 180. So remember, if you break this into 3 parts, you could do 30, 60, 90, or you could break it into 45s. So what I would do is I would probably break this into 3 parts. So this would be negative 90, 30 more would be negative 120, and 30 more would be negative 150. Now, if you had to break it down more, you'd have to divide 30 in half, and then that would be 15 degrees. So you have to break it down and show me how you're getting it. So the initial side would be here on this, and then this right here is the angle, and then you name it. So by showing this, I know that you know this is 30 degrees away from negative 180. So where's the angle lie?
Quadrant 3.
Right. Do you see what I'm saying though? You have to show me how you're dividing it into fractional parts. Also, like if you were trying to divide things into 3 parts, you might want to erase this because that's not helping you divide into 3 parts. So remember, you need 3 equal parts, right? So sometimes the axes are confusing when you're trying to make it into 7 parts or 9 parts or an odd number of parts. All right, anybody else want to ask me about something? Well, some common errors with this assignment is students draw line segments instead of a ray. So make sure that your angle has arrows on it. Sometimes students don't label the axes. Make sure you label, because we're going to be real strict about this in the higher level math classes, X and Y. Make sure you name the angle and make sure you show the fractional parts. All right, anything else for today? All right, you guys, have a great day. Have a great day. I'll see you later. Hey, is Gabriella still there? Are you still out there, Gabriella?
Ms. Birch, I had a question about CAS testing. Are we going to
Yeah.
be contacted if we still need to complete it?